All right, let's learn how to solve radical equations. Let's begin by solving equations that contains radicals. Solve the following equation. So we have the square root of x equals 8. So here I chose a simple radical equation because what I wanted you to do was guess at what you thought the answer was. So what you're doing is figuring out the square root of x equals 8. What is x in this case? Can you guess? So of course x represents an unknown number, but in this case we can probably figure it out because we're saying the square root of something equals 8. The square root of what number equals 8? So take a guess at what you think x equals. The square root of what number equals 8? So if you said 64, then you are correct. The square root of 64, let me place it here, and if we write is the square root of 8, and then the right side equals the square root of 8, therefore the left hand side equals the right hand side, and this is how you check your answer. You will always substitute x for what you're saying will work for that particular equation. So we're saying 64 works because the left side equals the right side. Let's move on. For more complicated radical equations, we're going to follow these 4 steps here. Step 1, isolate the radical, meaning try to get the radical alone on one side. And notice up here, the radical was on its by itself. Only thing on the left side is that radical, nothing else. Step 2, square. In this case, since we had a square root, we would square both sides. And why are we squaring? Because if this is a square root, these are inverses of each other, and what happens is it will cancel out. So if we square the left side, we will square the right side, for example. And notice if you square the left side, you're just going to get x because these are inverses of each other, then the radical goes away. And on the right side, of course, 8 equals 64. So this is the steps you use to get to that 64 when you can't just guess the answer. And then you're going to solve a variable. In this case, we didn't have to because x is already on one side. But always check the solutions and all of the potential solutions, because some of those solutions are called extraneous solutions, and I wish they wouldn't say they were solutions, but you'll get some results and you have to figure out if those results actually work when you substitute it back into the original problem. Sometimes it doesn't work, and they're called extraneous solutions that we have to eliminate from our solution set. All right, let's work on example 1 using those steps that we just went over. Now, step 1 was to isolate the radical. I want you to notice that the radical is not by itself because we have the radical here, but we have all of this stuff on the same side as the radical. So we're going to have to get rid of that, okay? So how do we get rid of the 2 that's on the left side? So we get rid of the 2 by subtracting 2 from both sides, right? If we subtract 2 from both sides, then that'll get rid of the 2 on this side. And then you have the square root of x equals 4. Now, and we get 4 because 6 minus 2 is 4. Now we're at the point where we had the previous problem, where there's a radical on one side and it's a square root. So to get rid of it, we will square since it's a square root. If it was a cube root, we would cube it. If it was a fourth root, we would fourth it. If it was the fifth root, we would fifth it, for example. But whatever we do on one side, we must do it to the other side. So now we have the square root of x squared is just x because that disappears. So we have x on the left side equals 4 squared, which is 16. Again, we have to check the potential solutions here. So we have originally the square root of x plus 2 equals 6. And we're saying that x equals 16. So we're going to replace it with 16. And then we're going to simplify the left side. Keep the left side on the left side when you're checking. And this is the left side of the equal sign. And this is the right side of the equal sign. Just keep the left side on the left side. Don't try to move things to one side or the other. Square root of 16 is 4. We have the plus 2. Does it equal 6? So again, keep this side over here. So 4 plus 2 is 6. And then we can just bring down the 6 on the right. So because the left hand side equals the right hand side, we say that x equals 16 is indeed our solution. So please don't get it mixed up that the solution is 6. We're just checking on the right side. We're not, that is not our solution. Our solution was x equals 16, and we verified it with this little check on the right side. Let's move on to example 2. Our radical is already isolated because the only thing that's on the left side is the radical. Everything is under that radical. So we're good to go. Let's square both sides since it was a square root. And then we get 3x minus 2 equals 25 this time. And then now we have to solve for x. So we're going to add 2 to both sides. We get 3x equals 27. Divide by 3. X equals 9. Now, do we know if that's the answers? Don't know just yet. We have to check. So we're going to check. Square root of 3 times something minus 2 equals 5. We're saying that that something is 9. So let's keep the left side on the left side. That's 27 minus 2. And then 27 minus 2 is 5. And the square root of 25 is 5 equals 5. So the left hand side equals the right hand side. And therefore we know that the solution is in fact 9. Moving on to number 3. The radical is on one side by itself. It just happens to be on the right side this time. But we're going to square both sides. So on the left side we get x squared. On the right side we get x squared plus 5x plus 10. And then what I'm going to do is subtract x squared because I see that we can get rid of the x squared. That's going to be good because now we don't have to deal with the x squared term. Then we have 0 equals 5x plus 10. We're going to subtract 10 from both sides. We're going to get negative 10 equals 5x. Divide by 5. X equals negative 2. Now we have to check to see if that's in fact the right answer. So the original was x, and we're saying it's negative 2 equals. So here it will be negative 2, and that's going to be squared plus 5 times a negative 2. And then we have that plus 10 on the end. So negative 2 equals the square root of negative 2 squared is positive 4 minus 10 plus 10. That's going to cancel out there. Negative 2 equals the square root of 4. Because negative 2 equals positive. It just doesn't work out, okay? Negative 2 doesn't equal 2. Therefore, negative 2 is actually not the answer. And since that's the only solution that we were able to come up with, there was only one solution for this. And since that didn't even work, we're going to say no solution. We're going to conclude no solution at all for this particular problem. So sometimes you end up with 2 solutions and one doesn't work, and you still end up with one that actually works. But in that case, since we only had one result and it didn't work, we're going to say no solution. Let's move on. We have the square root of 2x minus 3 equals x minus 3. We're going to square both sides since this radical is already on one side by itself. So we're going to square both sides, and we have 2x minus 3 on the left side. Right side, what is x minus 3 squared? So this is going to be on the final exam. This part, an example like x minus 3 squared, what is that? Now, you need to know that there's no shortcut way of doing that. So if you said x minus 3 times x minus 3, you are right. You have to write that out twice or else you'll get the wrong answer. So you have 2x minus 3, and then we're going to FOIL x squared minus 3x plus 9. So 2x minus 3 equals x squared. We have like terms in the middle, minus 6x plus 9. And then if you follow the rules of solving equations, you're supposed to put everything on one side. And I know that because I have this x squared term and I can't get rid of it. So let's subtract 2x from both sides. We'll get negative 3 equals x squared minus 8x plus 9. But also we need to add 3 to both sides as well. And then we'll get 0 equals x squared minus 8x plus 12. Now, second step of solving equations is factor. So you got to factor that trinomial. What factors of 12 add up to negative 8? What factors of 12 add up to negative 8? So negative 6 and negative 2. Then we're going to set each factor to 0. So we get x equals 6 or x equals 2. However, you have to check both of those, right? So you have to check. Let's first check when x equals 6. Does 6 work? Square root of 2 times 6 minus 3, does it equal 6 minus 3? So that's the square root of 12 minus 3 equals 3. Square root of 9 equals 3. 3 equals 3. So that definitely works. Now we need to determine whether 2 is an answer. So let's determine if 2 is an answer. Alright, so we're going to put in here 2 for x to determine if 2 is also a solution. So 2 minus 3. So that's 4 minus 3 here, negative 1. So that's a problem. We have 1 over here. We have negative 1 over here. So 1 doesn't equal negative 1. Therefore, 2 is not a solution. And you'll only submit 6 as your answer. Or circle 6. You'll cross out the other answer. Moving on, we have square root of 4 minus x equals x minus 2. We're going to square both sides to get 4 minus x equals x minus 2 times x minus 2. Again, you need to write that out twice if you have a binomial squared. 4 minus x equals x squared minus 2x plus 4. Then we're going to put our like terms together in the middle. So we get x squared minus 4x plus 4. Then we're going to subtract 4 from both sides. That's going to get rid of these numbers. And you can go ahead and add x to both sides. So you get 0 on this side since you cancel everything out from the left side. X squared, what is negative 4x plus x? That's negative 3x. Then, so now we have everything on one side. Then we factor. That's the second step of solving equations. We take that x out. That was our GCF. Then we're going to set each one of these to 0. Each one of the factors. So x equals 0 could be an answer, or x equals 3 could be the answer. But what do you think we have to do now? Yep, we have to check. So the square root of 4 minus 0, does it equal 0 minus 2? Well, you have the square root of 4 and you have negative 2. So that's not going to work out because we get 2 equals negative 2. But now let's try the other solution, which is 3. So does square root of 4 minus 3 equals 3 minus 2? Well, 4 minus 3 is 1, so the square root of 1 equals 1. Yes, so the only solution for this particular problem is x equals 3. Moving on to number 3. The problem here is that we have not isolated our radical first. So notice that we have this 5 on this side. We got to get rid of that first because it's not under the radical. So we're going to subtract 5 from both sides, and that's going to leave us with the cube root of x plus 1 equals negative 2. Now what do we have to do after we've isolated this? So what is the second step? Well, we're going to have to cube both sides because we have a perfect cube. And because we have the same number here and the same number here, the radical goes away because they are inverses of each other. And we have just x plus 1 on the left side equals negative 8. Since a negative 2 times a negative 2 times a negative 2 is negative 8. And then we're going to subtract 1. X equals negative 9. Then we're going to figure out if this works. So the cube root of negative 9 plus 1 plus 5 equals 3. So the cube root of negative 9 plus 1 is negative 8. We have that plus 5 equals 3. The cube root of negative 8 is negative 2 plus 5. Does it equals 3? Yes, negative 2 plus 5 equals 3. And the right hand side is 3. So that's how we know that negative 9 is really the answer. This is a little bit more complicated because notice that we have radicals on both sides. It's best to have one radical on one side and the other radical on the other side if you happen to have two radicals. So we will square both sides still here, and then we'll just get that 21 plus x on the left side, which is good. But since this is a binomial on the right side, please note that you will have to FOIL all that out. I know that's complicated, but you're going to have to do it. 3 times 3 is 9. 3 times radical x is 3 radical x. Again, 3 radical x. And you have, what's the square root times the square root of x times the square root of x? It's the square root of x squared, which is x. Then we're going to put our like terms together in the middle here. These are like terms. We can put them together. 6 radical x plus x. Now what we're going to do is try to isolate this radical. We only have one radical now, so we're going to try to get rid of all the other stuff. And since the radical is on the right side, we're going to try to get everything on the left side. So let's get rid of this x first because it's just bothering us. So we're going to get rid of it. That gets rid of that, and we have 21 equals 9 plus 6 radical x. Now let's get rid of that 9. So we're going to subtract 9, and we're going to get 12. 21 minus 9 is 12 equals 6 radical x. How do we get rid of this 6? So we still got to isolate that. We got to isolate it by dividing by 6. So now we're going to have 2 on the left side because 12 divided by 6 is 2. And you're going to have the square root of x on the right side. We still have to solve for x. We isolated our radical. So now we're going to need to square both sides to get rid of that radical. So we have 4 equals x. Is that the solution? Well, we can determine that by plugging in 4. So radical 21 plus 4, does that equal 3 plus the square root of 4? So what we're doing now is checking by plugging in the solution into our original problem. Then we have the square root of 25. Does it equal 3 plus 2? Yeah, square root of 25 is 5. 3 plus 2 is 5. So the left-hand side equals the right-hand side. So therefore, it checks out. Our solution is what? It's x equals 4. Moving on to number 5. Notice that our radical is not isolated. So we're going to first subtract. So subtract 3x from both sides, and we get the square root of negative 10x minus 1 equals negative 3x. We're going to square both sides since this is a square root. So we get negative 10x minus 1, since the radical goes away, equals 9x squared. We can't get rid of that x squared term, so we're going to move everything to the right side. We're going to add 10x to both sides first, and we're going to add 1 to both sides. So now we have 0 on the left side equals 9x squared plus 10x plus 1, but we can factor that, and I'm going to guess at the factors. 9x plus 1 times 9 times x plus 1. 9x plus 1 times x plus 1. And you can always verify that by foiling your head to make sure it is 9x squared plus 10x plus 1. So that's 9x squared plus 9x plus 1. So that works. And now you're going to set each factor to 0. So 9x equals, we'll subtract 1, negative 1, divide by 9, x equals negative 1/9. And then over here, x equals negative 1. So these are the two potential solutions. But of course, you're going to have to check those solutions. Now, if I check the negative 1/9, which is the harder one, then you will have square root of negative 10 times negative 1/9. You're going to have to know how to deal with those fractions. So if you plug that in, you get negative 10 times negative 1/9 is 10 over 9. Then you have that minus 1. What is 3 times negative 1/9? Negative 1/3 equals 0. 10/9 minus 1 is, if you make that a 9 over 9, that's 1/9 minus 1/3 equals 0. And what's the square root of 1/9? If you look at the square root of 1/9, that's the square root of 1 over square root of 9. That is 1/3. So this is 1/3 minus 1/3 equals 0. Believe it or not, negative 1/9 is one of our solutions. But we're going to have to check to see if x equals negative 1 is also a solution. So that's an easier one. What you should do is pause it to see if you get the right answer. So pause the video and check negative 1 as the solution. So hopefully you did it by now. If not, pause and then play again after you have checked it. So you plug in negative 1 here. You get the square root of 10 minus 1 minus 3 equals 0. Square root of 10 minus 1 is 9. Minus 3 equals 0. So you get 3 minus 3 equals 0, which is 0 minus 0 equals 0. So it checks out as well. So here you have answers because you have x equals negative 1/9 or x equals negative 1. Both of those actually work. So in this case, you had two solutions. Last, I wanted to touch on the fourth root of something. Now, what does that mean in light of what we've done already? How would you get rid of the radical there? And of course, we talked about it before, but you would simply just take the left side to the fourth power and take the right side to the fourth power. And then you'll have x plus 1 on the left side equals 2 times 2 times 2 times 2 in your calculator, or 2 to the 4, which is 16. Then you'll subtract 1, x equals 15. And then you'll verify that by checking your answer, and you will find out that it's actually the solution when you check your answer. But I just want to touch on that to make sure you know that you can attempt all of these type problems, even if it went up to the 100th power or the 100th root, you can still solve those radical equations. So this concludes the lesson on solving radical equations.